Hey, all you cool cats and kittens. My name is Michael Lathrop, and today we're going to talk about the atmospheric circulation. Going to do a quick little PowerPoint presentation. Really got some sweet slides and some really nice pictures that I hand drew myself on paint. So, quick little overview. Let's talk about the wind, what it is, how it's formed. After that, we're going to move on to the Coriolis effect. Have on here that the Earth is round, not flat like some people might say. That has an effect on the wind. Let's find out what that is. Moving on to why air rises and falls. What are some of the causes of this? And finally, we'll kind of touch on the climate, wind circulation, and the effect on climate. Quick little diagram here. Previously in the video that I filmed before this, we spoke on what causes air to kind of rise and fall and what causes the movement of air. Well, this diagram explains a little bit further on that. So when you have a area of cold, you have an area of high pressure. The reason for that is the cold air weighs more, it's more dense, and it's falling down to the earth. And when it's falling down to the earth, it creates an area of high pressure because of the weight of this cold air. And then over here where it's hot and sunny, you've got an area of low pressure. And the reasoning for that is because, as we spoke previously, those air parcels are wanting to rise up, creating an area of low pressure down at the surface. So what happens is you've got the area of high pressure wanting to move towards the area of low pressure, trying to find the equilibrium. Well, by doing that, it's creating a wind. So all this air over here in the cold, high pressure area wants to blow towards the hot, low pressure area. So if you have a lot of temperature variations between night and day or from day to day, there's going to be a lot of winds associated with that. And that's because of the temperature changes. High to low pressure. So let's talk about the Coriolis effect. What is that? You know, we mentioned that the Earth is not flat. The Earth is round, and the Earth not only is it round, it's spinning. So it's constantly moving. Well, when we think about the fact that the Earth is a sphere, that has an effect on the wind. So this spinning sphere, the Coriolis effect changes air into a curved direction due to the rotation of the Earth. If you're in the northern hemisphere, the wind wants to curve to the right. If you're in the southern hemisphere, the wind wants to curve to the left. And this has to do with that rotation of the Earth. So you had a wind that was blowing south, and now you have a wind that's starting to blow easterly, or westerly, excuse me. And then if you're in the southern hemisphere and you have a northern blowing wind, it would start wanting to blow more westerly because of that curve. And this has an effect on storms as well, and as well as climate, and we'll talk a little bit more about that here coming up. So why does air rise and fall? The most powerful force which causes air to rise and cool is the sun. And when the sun radiates heat on the surface of the earth, warming all the air above the ground takes place. This warm air rises and cools as it goes higher until it reaches a certain point where condensation will form and clouds will form and you'll reach your dew point. So sun comes in, warms the ground, warms the air above the ground by convection, and then the warm air rises, cools a little bit, rise and cool, rise and cool. So at the surface, creating an area of low pressure, and then nice happy clouds up in the air. That's just one of the reasons why air might rise and fall. Another reason would be if a area of a cold storm moves on a warm mass of air. And this will cause air to potentially have the cold air force itself under the warm air, and it'll rise up, creating a front. And that's how thunderstorms are made. But we'll talk on more on that later in a different video. So this little diagram will talk a little bit more about the winds. So we talked about how the Coriolis effect has an effect on the way the wind changes its direction. So it has a curve. Well, not the only place that occurs isn't just between 0 and 30 degrees. It happens between 30 and 60 degrees, 60 and 90 degrees. So, but this curve changes depending on where it is on the earth. So between 30 and 60 degrees, you're going to have the curve be more to the point where it's westerly. So what I mean by that is you'd have a wind that's blowing from the west to the east, and that's known as a westerly wind, and that's between 30 and 60. Same on the southern pole, between 30 and 60, you've got a westerly blowing from west to east. If you go past 60 degrees to 90, you've got what's known as an easterly, blowing from the east to the west. And these little diagrams on the side just kind of show the air movement on the planet, the air circulation. So the air gets warm, rises up, makes clouds, falls back down again. And what tends to happen is a lot of moisture stays around the equator. At 30 degrees north and 30 degrees south, you have a lot of dryness. And then at 60 degrees north and 60 degrees south, you're going to have a lot of snow, a lot of ice. So we'll just read this here real quick. Moist rising air near the equator cools and condenses into clouds and later rain. As the current of air moves towards the pole, the air releases much of its moisture. By the time the current turns back towards the equator, the air is descending, becomes compressed and warmer, and its relative humidity falls further. So under these conditions, it's rare for clouds and rain to form, thus creating the deserts at 30 degrees north and south. So I've added a little bit more to this picture. So we've got a picture that I had to change a little bit because I needed to update my annotations on here. So this is what I was talking about with the winds. Added on here that we have the westerly winds blowing from west to east, the easterly winds blowing from east to west, and then we've got the trade winds between 0 and 30 degrees that are blowing from the east to the west. So those would also be known as an easterly wind, but a tropical easterly wind. They're known as the trade winds because back whenever sailing occurred all the time, they would use the trade winds to sail from Africa and Europe over to North America and South America with the winds at their back and helping them sail faster. And that created these trade paths. And then I put on here as well the deserts that are forming at 30 degrees or have formed at 30 degrees north and 30 degrees south that we spoke on. So the Coriolis effect also has an effect on storms and how they occur at different places. Let's take, for instance, a hurricane, an area of low pressure. The air is going from high to low pressure, high to low pressure. So you've got a low pressure center, and all the high pressure air around it wants to find its way into the center. So the air is wanting to go just straight inward. However, you've got the Coriolis effect. So in the northern hemisphere, that air wants to curve to the right. In the southern hemisphere, that air wants to curve to the left. So when you see hurricanes north of the equator, they're going to want to rotate counterclockwise. If you see a hurricane south of the equator, it's going to want to rotate clockwise. The same can be said for tornadoes. Tornadoes in Oklahoma. Almost every single tornado you see will be rotating counterclockwise. And that's going to be it for my brief little video. I hope you enjoyed it and found it informative, and I appreciate your watching. Thank you.